We're doing exercise 8.b, differentiating using the first principle or the definition of derivative. I have my function f of x is equal to x square, and we are asked to find f dash. We are asked to show that f dash 2 is equal to 4. We know that the derivative of a function f of x at a point x is equal to a. X can be equal to a, x can be equal to 2, x can be equal to 3, 4, or anything, is defined as f dash a is equal to limit h tends to 0. F of, instead of x, I'm writing a. So f of a plus h minus f of a divided by h. So here my f of x is x square. So f of a would be a square. Instead of a, I'm going to put 2. So f of 2 would be 2 square. And f of 2 plus h is 2 plus h, the whole square, because I'm asked to find f dash 2. So I go ahead with it. F dash 2 will be equal to f of 2 plus h minus f of 2, the whole divided by h, and limit h tends to 0. So this is equal to limit h tends to 0. Instead of 2 plus f of 2 plus h is nothing but it is 2 plus h the whole square, and f of 2 is nothing but 2 square divided by h. So this will be limit h tends to 0. 2 plus h the whole square is nothing but a square plus 2ab plus b square minus 4 divided by h. This plus 4 and minus 4 gets cancelled. So what I am left with is limit h tends to 0, 4h plus h square divided by h. So it is going to be limit h tends to 0, 4 plus h. So since h is tending to 0, so f dash 2 is nothing but it is equal to 4. Because as h is tending to 0, I will put h is equal to 0. Come on, over here. The B part of this question is the same question. For the function fx is equal to x square, use the definition of derivatives to show that f dash minus 3 is minus 6. So we know that the derivative of a function at a point x is equal to a. Okay, derivative of a function at a point x is equal to a is defined as, how is it defined as? Come on. F dash a is equal to limit h tends to 0, f of a plus h minus f of a, the whole divided by h. So here a is equal to minus 3. Okay. And f of x is equal to x square. So f of a will be equal to a square. So f of minus 3 will be equal to minus 3 the whole square, and f of minus 3 plus h will be equal to minus 3 plus h the whole square. Okay, so f of a and f of a plus h. Now I put the formula. Limit h tends to 0. F of minus 3 is equal to. I'll put this over here. F of minus 3 is equal to limit h tends to 0. f of minus 3 plus h minus f of minus 3, the whole divided by h. So it is limit h tends to 0, f of minus 3 plus h is nothing but minus 3 plus h the whole square minus minus 3 the whole square, the whole divided by h. Now a plus b the whole square, a square. I will not forget to put limit h tends to 0. A square plus 2ab plus b square. The minus sign is over here and minus 3 square is nothing but it's 9. The whole divided by h. So this is limit h tends to 0. Minus 3 the whole square is 9. 2 into 3, that's minus 6h plus 8 square minus 9, the whole divided by h. 9 and 9 gets cancelled. So my f of minus 3, okay, so it's f dash minus 3 is limit h tends to 0. I will divide throughout by h, so minus 6 plus h. So f dash minus 3 is equal to, as h tends to 0, h will be equal to 0. So f dash minus 3 is equal to minus 6 plus 0. So f dash minus 3 is nothing but it is minus 6. Now keeping this in mind, I want you to try the C part and try the D part. Okay, exercise 8B, question number 1. Exercise 8B, question number 1. We are doing the third part. You want to show that f dash 0 is 0. You know that the derivative of a function f of x at a point x is equal to a is defined as f dash a is equal to limit h tends to 0 f of a plus h minus f of a. My a over here is 0, or I would say my x is 0. Okay, so f of x is x square, f of a is 0 a square, so f of 0 would be 0 square, and f of a plus h, that is 0 plus h, would be 0 plus h the whole square, that is h square. Then I would say f dash 0 is equal to limit h tends to 0 f of 0 plus h minus f of 0, the whole divided by h. So its limit h tends to 0. Instead of 0 plus h, I'm going to write h square, and f of 0 is 0 divided by h. So it is going to be limit h tends to 0. H f dash 0. So as h tends 0, h will be equal to 0. So f dash 0 is going to be 0. Similarly, the next question over here, the D part. F dash 50 is 100. I know that the derivative of a function f of x at a point x is equal to a is defined as f dash a is equal to limit h tends to 0 f of a plus h minus f of a, the whole divided by h. So here my a is nothing but it is 50. F of x is x square. So f of a will be a square. So f of 50 plus h, it is going to be 50 plus h the whole square, and f of 50 will be 50 square. Then I put it in the formula f dash 50 is equal to limit h tends to 0 f of 50 plus h the whole square f of 50 plus h minus f of 50, the whole divided by h. So it's going to be limit h tends to 0. F of 50 plus h is nothing but 50 plus h the whole square minus 50 square the whole divided by h. And when you're going to solve this further, you know how to solve it now. You're going to get f dash 50 is equal to 100. So with this, I complete exercise 8B, question number 1, the A, B, and C, D. It is year 1 Excel differentiation.